Hello everyone, welcome to our channel. I am Kaushikar, a management student of University of Peradeniya. As the continuous assessment, we are going to solve three challenges from the content of decision making under uncertainty. So our group number is group number 6 and the first question is from expected utility approach, second question is from game theory and the last question is from Nash equilibrium. Let's move on to the first question. There are three red balls and six other balls, which could be black or yellow. But we don't know the exact number black ball and yellow balls. The decision maker is going to choose one ball out of those 9 balls, and there are 4 options for the decision maker. Option A, pays of 1000 rupees if a red ball is drawn, otherwise 0. Option B, pays of 1000 rupees if a black ball is drawn, otherwise 0. And the decision maker says she prefers A more than B. Option C, pays of 1000 rupees if a red and yellow ball is drawn, otherwise 0. And option D, pays of 1000 rupees if a black or yellow ball is drawn, otherwise 0. And the decision maker says she prefers D more than C. The question is to urgent that these performances are not consistent with the things we learn about decision making under uncertainty and the theory of expected utility. Our group member Pasandu will provide answer for this question and I invite to him.
Thank you, Kaushika. As per the question, when we calculate expected utility for option A, the decision maker will get 333.33 as the expected utility for choosing a red ball overseas 0. But for option B, we can't calculate the expected utility as we don't know the exact number of black balls available. It can be 3, 4, or 5. Similarly, for option D, we can find the expected utility because the probability is available. But for option C, we can't find it because we don't know the probability of talking yellow balls. Without calculating the expected utility for all the options, we can't compare the options and make correct decision. So as the given data is not enough to make correct decision, we can't apply what we learn is decision making under uncertainty to and expected utility theories in situation. Over to you, Supani, to do the rest of the presentation.
Thank you, Pasindu. The second question is, consider this game. Suppose that players play simultaneously over many periods. In each period, each player best responds to the action played by the opponent the period before. Assume that in period 1, players start with the strategy provided. There are middle and left. Here is what we are taught. Describe play in the next 7th period and a pattern emerge. Okay, we try to find out Nash equilibrium for this one. We have there 3-3 matrix. We consider row as player 1 and column as player 2. Player 1 get up, middle, down, and player 2 get left, middle, and right. Okay, let's move on to the solving this now. Here, each player is using the best strategy for the previous strategy of the opponent player. So, if the strategy for the first period is middle and left, player 1 will choose the best strategy for left, which is middle, and player 2 will choose right, the best strategy for middle. Then in second period, their strategies are middle and right. If the strategy for the third period is up and right, player 1 will choose the best strategy for up and player 2 will choose the best strategy for right. If the strategy for the fourth period is up and middle, player 1 will choose the best strategy for up and player 2 will choose the best strategy for middle. Then if the strategy for the fifth period is down and middle, player 1 will choose the best strategy for down and player 2 will choose the best strategy for middle. After that, if the strategy for sixth period is down and left, player 1 will choose the best strategy for down and player 2 will choose the best strategy for left. If the strategy for seventh period is middle and left, player 1 will choose the best strategy for middle and player 2 will choose the best strategy for left. Finally, the strategy for 8th period is middle and right. Player 1 will choose the best strategy for middle and player 2 will choose the best strategy for right. Now, here we can see in the 7th period, they have come to the starting point again. And again, the same rotate happened after the 7th period. If player 1 wins in the first period, player 2 wins in the second period. If player 2 wins in the second period, then player 1 wins in the third period. Like that, same thing happening each and every period we can see. And other things also, no one is getting 0 here. In each and every period, they are getting some payoff. Okay, let us now move on to the third question. It's up to you, Malisha.
Thank you, Subhani, for your clear explanation to the question number 2. So let's move on to question number 3. Actually, this may be a tricky question for the students, but we are try our best to explain this question in a clear manner to get a proper understanding. Okay, so let's move on to question number 3. This is a voting game. In here, there are 3 players called 1, 2, and 3, and also there are 3 alternatives A, B, and C. In here, there's a one condition that the abstaining is not allowed. It means everyone has parts for the vote either A, B, or C, and the alternative with the most votes win. If no alternative receives a majority, so the option A is going to be selected. So they have already given the utility that got by each player for choosing each alternative. That is depicts in the following payoff function. According to preference order, we can say that the player 1 prefer A to B to C. In here, the higher preference to A and the low preference to C. The player 2 prefer to B to C to A. The player 3 prefer C to B to A. So they are asking from the part A, show that the PO strategy profiles A, B, A and the AA are both Nash equilibria. From the part B, they are asking if A, B is a Nash equilibria or not. So for the question A, the Dinosha will provide the answer.
Thank you, Malisha. Even though this question is a little bit hard, if you understood it correctly, it's going to be easier. So here there are 3 players playing in this voting game. Therefore, we are going to draw 3 payoff matrices, because when one player is choosing an alternative, the other 2 players can come up with 9 different alternative combinations. Therefore, there are 27 in total. Here, I have provided a small payoff table for you, which shows the payoff for each player when each alternative is selected. Let's consider the first situation. When player 1, 2, and 3 vote for A, then A will be selected as the final alternative because of the majority of votes. If A is selected as the final alternative, then player 1 will get 2, player 2 will get 0, and player 3 will get 1 as their payoff. In the second situation, when player 2 vote for B and if player 3 vote for A and if player 1 vote for A, then there is a majority of vote for option A again. Then A will be selected finally. Then 2, 0, 1 will be the outcome or the payoff again. Then like that, we have to fill all this part of payoff matrices, and then we have to highlight the best payoff for each player when each alternative is selected. Let's consider the first situation when player 2 vote for A and player 3 vote for A. Player 1's vote is not going to change the final result because there is already a majority for option A. Then player 1 will be feeling indifference between all these options. Player 2 and 3 will also feel the same, because when the other 2 players are choosing A as their option, they will feel indifferent between their options. So next, in the second situation, when player 2 vote for B and player 3 vote for A, then player 1 will select either A or C to get the highest payoff for him. Likewise, when we fill all the part of best payoffs, we can come to a conclusion that there are 5 Nash equilibria in these payoff matrices. Our question is to prove that AAA, ABA, both are Nash equilibria. We can see that in the payoff matrices. So we can say AAA, ABA, both pure strategy profiles are Nash equilibria because none of the players are willing to change their option in those situations, because even if they change, that is not going to give any better payoff for them. So hope you understood this question, and our next answer will be provided by our team member Malisha.
Thank you, Dinasha, for your answer. So the next question is asking, is AB is a Nash equilibrium or not? In here, the payoff matrix, we can see that the player 2 choosing A and the player 3 choosing C, the best option for the player 1 is to be A or C. So in the play 1 is satisfied. And when it comes to the player 2, the player 1 chooses A and the player 3 chooses B. The best option for the player 2 is going to be B. So definitely player 2 is not satisfied. And when it's come to the player 3, when player 1 is choosing A and the player 2 is choosing A, the player 3 is satisfied. That is okay. But since the player 2 is not satisfied with the option A, choosing the alternative A, so we can conclude that the AAB is not a Nash equilibrium.
We hope our video was useful for all of you. So if you have any doubts or questions, please mention in the comment section. Thank you so much for watching.